I'm Jehovah Yi here. So today I will talk about LED 2 basic circuit of, and I will do the part 1. I will demo some circuit here to you. So part 1 is about clock D flip-flop. So I will talk about clock D flip-flop. So unlike the SR flip-flop, clock D flip-flop has only one synchronous control, D here. D means data. So the operation of D flip-flop is very simple. So Q will go, when Q will go to the same state that is present on D. So basically what it means is that when D, value of D is 1, Q will also get the value of 1, provided that the clock is a PGT. PGT stands for positive going transition, which means when the clock changes from 0 to 1. So as you can see here, so when the D is 1, the clock here is a PGT. It changes from 0 to 1, so the value of Q here become 1. So this is the whole concept of the idea of D type flip-flop. So now I will demonstrate on this diagram on the circuit. So this is our D, and this is the clock, right? Clock, and this is the Q. So as you can see here, 0, 0. Q will not, the bar here, Q will not light out. There will be nothing. But now D is 1, clock is 0, and Q still will not light out. So until here, since here there is a PGT, which is positive going transition occur here, which the clock changes from 0 to 1. So now the D is 1, clock is 1, so the Q, the bar here, Q light out. And until here, NGT occur. NGT stands for negative going transition, which means the clock changes from 1 to 0. So now the value of D is 1, still 1, but the clock value becomes 0, and the Q will still light out. So until here, D 0, 0. Since this is still a DGT, NGT, negative going transition, the bar here will still light out and will go off soon because there is some delay for the circuit. And until here, PGT occur again. The clock changes from 0 to 1, but now D is 0, so Q will still be 0. And this is the same for all the other circuit until here. 0 changes to 1 again. 0 changes to 1. So now D is 1, clock is 1, then Q will light out as expected. Q is 1. So in conclusion for this part, whenever the value of D is 1, Q will also get 1, provided that the clock is a DGT or PGT, which is NGT and PGT, which is negative going transition. When the clock changes from 0 to 1, or the clock changes from 1 to 0, the D and Q value will be the same. That's the whole concept of this part. Thank you.
Okay, now we are going to start part 2. The part 2 we are expected to get this graph in the oscilloscope, which is this. To get this graph, we have used the HC74 IC, and this is how it's connected as in the lab sheet, where the D is connected to the Q dash, and the Q dash is connected to the output, which is X, and that is connected to the channel 2, and the channel 1 is connected to the clock module, and so this is the graph we got in the oscilloscope. The same graph we got it in the lab sheet as well. As you can see here, like both are completely same, and when we have an input of 500 kilohertz and we get output of 250 hertz. So that's the expected results. We got it here. So yes, thanks. Got it.
So now we will talk about Lab 2 Part 4. So this part is about the dies, LED dies arranged in pattern of the dies. So as you can see here, this diagram. So you need for the one, you need A to make this dice row 1. So you need D to make 2. You need A and D to make 3, and you need CD to make 4, and 5 is S plus D, A plus C plus D, and the 6 is B, C, D. Okay, so now I will explain about the part 4 schematic diagram. So how do we come out with this diagram is we use the Carnot mat here, and then we found out the A, B, C, D, and then we sketch out this diagram. So this diagram is made out of one Q1 is connected to the NAND gate, and the NAND gate to the B, and the Q2 is connected to the NOR gate, and then the NOR gate is connected to D, and Q0 is connected to A. So part 5 is about part 3 and 4 combined together. So I will show you this board. So as you can see here, our board is running well. So you see this is the part 3 and this is the part 5. So which is making the dice here. See, yeah, 5. Okay, 6. Yeah, done. Over again. So today I will discuss about Lab 2 part 3. So in this lab, we will talk about 74 HC161 for byte synchronous counter that count out from 1 to 6. So in this experiment, we use a HC00 NAND gate for us to count out from 1 to 6. So this is our wiring. As you can see here, this is our master reset. So the master reset is connected to the 1A of the 74 HC161, and the other thing I want to highlight here is this clock module is connected to the second of the HC161. Okay, and so in this diagram, this is how we connect the whole circuit. So in this diagram, this D0 to D3 is our input, and Q1 and Q2 is as our output. So the Q1 and Q2 is connected to the HC00, which is the first NAND gate. Then the first NAND gate is connected to the second and the third. So the third NAND gate is connected to the CEP. So yeah, 7. Yeah. So this is connected to the 7
pin of
SIM 7 pin of 616. So and the NAND gate is connected to the PE 9, which is 9 of the 161. So now I will show you how it works. So first you press the master gate and then wait for the things to run out, then you release it. So let's just count again. 1, 2, 3, 4, 5, 6. Okay, reset again. 1. That's all from me. Thank you.